Hello and welcome to lesson 110. Today we're going to talk about money, and specifically money that you would take to the bank and ask them to deposit the money into your account at the bank. Now, if you have what is called an interest-bearing account, that means that the bank will pay you to hold your money. Okay, so there's some terminology that we need to talk about when it comes to this money that you take to the bank. So the first thing is what we call the principal. So the principal is the amount of money you actually deposit into the bank. So maybe you got a birthday card with $10 in it, and you take that to the bank and say, I'd like to deposit this $10 into my savings account. That $10 would be principal because that's the amount of money you deposit, which means give to the bank to hold, into the bank. Okay, the interest is the amount of money that the bank pays you. So they're going to pay you a percentage of what you deposited, or a percentage based on your principal. So that percentage they pay you is called the interest. Now, there are a couple of types of interest that we're going to talk about. One of those would be simple interest, and one of those would be compound interest. So simple interest is money that is paid on the principal only. So this is money that is paid on that amount you deposit only. So in other words, any other interest that you've received that stayed in your account, you will not get interest based on the interest you've already earned. The interest will only accrue on the principal that you deposited, and that is called simple interest. There is also something called compound interest, and this is where interest is paid on the principal, again the amount you deposited, as well as the accumulated interest. So any other interest that you've earned that stays in your account, if you have compound interest, you'll earn interest on that amount also. And we're going to take a look at how this works. Great, so this problem says to make a table that shows the value of a $1,000 investment, so that's the principal, the amount you deposited, $1,000, growing at 10%, compounded annually after 1, 2, 3, 4, and 5 years. So we're going to start by filling in the chart. So the number of years, we know 1, 2, 3, 4, and 5. So we're just going to put those in the blanks. Okay, and we're going to start with simple interest. So simple interest, okay, remember that interest is only paid on the principal amount. So after the first year, we have our $1,000. We're going to multiply that by 0.1 or by 10%. So we had $1,000 times 0.1 because it was 10%. And that's going to tell me how much interest I earned. So I earned $100 in interest. So I'm going to add that back to my $1,000. That would give me $1,100. And again, that's simple interest. Now, we'll go from our $1,100. My dog's starting to help me again. And we're going to multiply 1,100 by 0.1 for 10% interest. And that gives me $110. So $110, I'm going to add that back. So add that to my 1,100. After 2 years, I have $1,210. Okay, scratch that. I made a mistake. Backspace delete. Okay, so on my simple interest, I was trying to do compound interest. On my simple interest, I found out I'm going to make $100 a year. That's what I found out when I took my $1,000 times 10%. So add $100 to that. So after 2 years, I would have $1,200. Add another $100. I would have $1,300. Add another $100, $1,400. add another 100, and we would have $1,500. Okay, so that is with simple interest. The interest of $100 is added each year, and it's only based on that $1,000 that I deposited. Now, let's go back to the compound interest, which is what I was trying to do earlier. So the compound interest, okay, we will take our $1,000 and we're going to multiply that by 0.1 because it's 10%, and that will give me $100. So I started with 1,000, add my 100, and I get $1,100. Okay, just like I had with my simple interest. Now, however, we're going to take 1,100 times 10%, or times 0.1, and that will tell me how much interest I would earn on the second year. So I earned $110 the second year. Let's add that to the $1,100 we had, and now I have $1,210. So we can see a difference already after 2 years. I have 10 more dollars that I've earned. Well, let's see what happens for the third year. I take my $1,210 times 0.1. That equals $121. So I'm going to add my 121 to 1,210. So plus 1,210, and that will equal $1,331. Now I'm seeing a little bit bigger of a difference. Let's do times 10% from this. So times 0.1. Okay, this time I earned $133.10. Let's add that to the $1,331. And now I have $1,464.10. Okay, one more time to get year 5. So $1,464.10 times 0.1. This month, or this year, I earned $146.41. Let's add that to the $1,464.10. And I get $1,610.51. Okay, so what I can see here is that there is a noticeable difference between the simple interest and the compound interest after 5 years. So I have earned over $100 just by having compound interest. Okay, but it just is based on what the interest is paying on. Again, in simple interest, we only paid on the principal. So interest was going to be the same every single year. It was just going to add $100 every single year. Whereas with the compound interest, the first year it paid 10% on the original principal, but the second year it paid 10% on the total. The third year paid 10% on the total, and the same with the fourth and the fifth. That's why we ended up with more money in our savings account at the end of 5 years when it was compound interest. So using this example that we just completed with the compound interest, there's another way that I can figure that much more quickly, because what I did is I took 1,000 times 10%, added that to 1,000, and then wrote the amount. Then I took that times 10%, added that amount to 1,100, and then wrote it here. Okay, so there ends up being a lot of steps in doing that. However, there's a shortcut, and this is the shortcut down here. So I would take my original principal, the 1,000, and I'm going to be multiplying it by 1.1. Why 1.1? Well, this 1, if we put the 1 into percent, that would mean 100%. So that's going to include the amount I had before I started figuring interest again. It's going to take the total, the 100%. And then the 0.1, this is the 10%. So each time I'm getting 110% of the amount before. So let's see how that works. So I'm going to start with my 1,000. So there's my 1,000 times 1.1 equals. Okay, look at that. There's my $1,100. Okay, let's do it again. I'll move this up. Let's do times 1.1 equals. There's my $1,210. Let's do the third year. Times 1.1 equals $1,331. Times 1.1 for my fourth year. Times 1.1 for my fifth year. So $1,610.51. So this way, this multiplication I have at the bottom just makes it a little bit easier. Okay, why do I have 1.1 written 5 times? Because there were 5 years. If there were 4 years, there would only be 4 1.1s, or 3 years, there would only be 3. So each of those would be for the number of years, or for each year that the problem is asking about. So this problem says, use a calculator to find the value after 12 years of a $2,000 investment that earns 7.5% interest compounded annually. So we have compounded, so we know it's going to be compound interest. Okay, so how am I going to figure this out? Well, I'm going to start with my $2,000. Yes, I know it says use a calculator, and we will. But I'm going to have my $2,000. What am I going to multiply it by? I'm going to need my 1 point something. There's a 1 there because it's 100% of the $2,000. Now, how do I write 7.5% as interest? Well, if it were 7%, I know it would be a 0.07. But it's 7.5%, so I put that half on the end, or I put a 5 after the 7. So this is for 1 year. I need for 12 years. So 1.075, 1.075, 1.075, 1.075, and I'm going to have to write this 12 times. So 1, 2, 3, 4, 4 by 3, I've got it 12 times now. And that's how I'm going to figure out the amount of interest after 12 years. So let's do that. So I have 2,000 times 1.075, there's 1, times 1.075, that was 2, times 1.075, that was 3, times 1.075, 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 times 1.075 equals. Okay, so I come up with a pretty crazy decimal number. So I have to remember it's money, so I'm going to be rounding it to 2 decimal places. So I see in front of the decimal point, I have $4,763, and then I have a 558. Okay, so I need to round this to 2 decimal places. So it's either going to be 55 or 56. That 8 is going to turn this into a 56. So 0.56. So $4,763.56. Now, some of you may have already figured this out, but I do want to show you a little bit of a shortcut here. So I had my $2,000 that I started out with, times, and then I had 1.075, and I listed it 12 times. So that's the same thing as having it to the power of 12. So if you happen to have your good calculator at home, then this would be an easy problem to do. 2,000 times 1.075 to the 12th power. If you have a calculator like I have access to at home, it does not have exponents on it, so I just have to enter it manually 12 times, and I still get the same answer. But you will get the same answer if you're also using the exponent on the 1.075. Okay, this example says calculate the interest earned on an $8,000 deposit in 9 months if the annual interest rate is 6%. Okay, so we started out with an $8,000 deposit. Okay, it says the interest rate is 6%. Okay, so I could multiply this by 0.06, and what that's going to give me is how much interest has been paid for the year. So let's do that. So 8,000 times 0.06, and we would get $480. So $480. But remember, that was for the whole year. Okay, this says we need it for 9 months. Well, we know that 9 months is 3/4 of the year, because 9 out of the 12 months would reduce to 3/4. So 3/4 is the same as 0.75. So let's take our 480 times 0.75 so that we are only counting 9 months. So I had my 480 times 0.75 equals, so for 9 months we're only getting $360. And that is the interest we would have for those 9 months. Okay, the second part of your lesson today has to do with discounts. And we're looking specifically at successive discounts. So it would be one discount taken, and then there's another discount taken off of the discount price. So what we're doing is we are finding percents of percents. There are 2 ways that I can do this. 1, I can use 2 ratio boxes, or 2, I can consider what percent of the original price is represented by the new price. So I'm going to take you through both of these ways to finding successive discounts. All right, so here's an example of a successive discount problem. It says an appliance store reduced the price of a $400 washing machine 25%. When the washing machine did not sell at the sale price, the store reduced the sale price 20% to its clearance price. What was the clearance price of the washing machine? So I'm going to show you again both methods. So method 1 would be using 2 ratio boxes. I went ahead and labeled these for you. So we have percent and actual. The original price minus the change equals the new price. So we're going to start with the original price of the washing machine. The actual price was $400. So that's the original price, which was 100%. Okay, that was the whole price. It says they discounted it 25%. So that's the change, 25%, which I know then gives me a new percent of 75. What I have to find out is what is the new price. Okay, so I can write some ratios or some fractions equal to one another. So I have 100 over 75 equals, so I did original to new. Let's do original to new. So 400 over x. Okay, you might be able to tell by looking at this that I multiply by 4 to get 400. So I will multiply by 4. When I take 75 times 4, 5 times 4 is 20, 7 times 4 is 28, plus 2 is 30. So the new price that I get is $300. Okay, that new price is now going to go up here to the original price again. So it's like we're starting over because we're taking another discount. We're taking another 20% off. So this 300 goes up here. This is going to be 100% again. Okay, the new discount is 20%, so that will be the change. So the original minus the change, that will leave me an 80 right here. So I need to find out the new sale price, so I'm solving for this. So let's write a new proportion. We have 100 over 80 equals 300 over something. So 300 over x. Okay, to get from 100 to 300, I multiply by 3. So I need to multiply by 3. 80 times 3 is 240. Okay, so what was my clearance price? It was $240. So that's method 1 of coming up with a discount of a discount, again, successive discounts. Okay, method 2, the way that I'm going to look at this, I say, well, what percent is the sale price? Okay, if I go back up to the original problem, it was discounted 25%. So if I'm going to buy it, I'm actually paying 75%, which we can see illustrated in our first ratio box here. Okay, so what percent is the sale price? 75%. What percent is the clearance price? Well, they took 20% off, so what's left is the 80%. So 80% is the clearance price. Okay, so the clearance price, if I need a value of it, it is going to be 80%, which we got from here, of the 75%, which we got from here, of the 400, which was the original price of the washing machine. So all those ofs mean to multiply. So 80% is 0.8 of 75% is 0.75 of 400. Okay, so now I just need to do a multiplication problem. So how about we take 400 times 0.75. So 0.75 times, I'm going to use some hanging zeros here. So ignore those at first. 5 times 4 is 20. 4 times 7 is 28, plus 2 is 30. Now let's bring down those zeros. 2 decimals, 2 decimals. So I have 300. I need to now multiply that by 0.8. So 300 times 0.8. 8 times 0 is 0. 8 times 0 is 0. 8 times 3, 24. 1 decimal, 1 decimal. So what do I have? I have a clearance price of $240, which is the same answer I had up here, which is the answer that I wrote down beforehand to make sure we solved it correctly. All right, last problem here. So we have a television today. This television is regularly priced at $300. It was placed on sale for 20% off. When the television still did not sell, the sale price was reduced 20% for clearance. So what was the clearance price of the television?